I just okay. So I got that for any n, fn minus fn minus one equals f2 minus f0 over 2.
Let me write. Can you say it again?
I got fn minus fn minus 1 equals f2 minus f0 over 2. So I set that equal to m. So I get f is a linear function.
Yes, you can use. Let me tell you something. How you reach this?
I plugged in a 0 in n, and then I plugged in 1 in n minus 1.
Plus 2f of 0 is equal to f of you use the thing that I told you to get rid of complicated term, right?
Yeah.
Okay, 2n minus 2 plus 2 times f of 1 is equal to f of n. Oh, sorry. Here, 2n minus 2. So yes, f of 1 and f of n. N minus 1, yes. Then if you subtract, it will be what?
Then it will be just be 2 f of n.
I think you've used 0 for this one, right? Not this part. 0 and 2, 0 and 1 n minus 1, right?
Mm-hmm.
It is n.
Mm-hmm.
So f of n plus f of 0 is equal to f of n minus 1 plus f of 1 plus f of 2, right?
Yeah.
So f of n minus f of n minus 1. Oh, sorry, it is a 2f of 0, 2f of 2. So it is equal to 2f of 2 minus 2f of 0, right? I think you or let's say 2f of 2, f of this part is equal to this part, 2f of 2 plus f of n minus 1 is equal to f of n plus 2f of 0. So f of n minus f of n minus 1, 2f of 2 minus 2f of 0. So it is not over 2, it is 2, right?
Mm-hmm.
Understood your careless mistake here? You said over 2, but it is times 2.
Yeah.
I have careless mistake or you had careless mistake?
I'm trying to figure out now. No, it's not 2 f of 0. I think I'm right. It's not 2. It's just f of 0. It's not 2 f of 0. That's why. On both of the equations at the start, there's not a 2 there.
Here?
Yeah, you see 2 f of 0. It's not 2
Yes. Sorry. Here we don't have 2. So f of 0, f of... I consider this one, sorry, yes. So I had careless mistake here. So let's correct this. 2f of n plus f of 0 is equal to 2f of n minus 1. So f of n minus f of n minus 1 is equal to f of 2 minus f of 0 over 2, right? Which is m. Okay, how can we say it is a linear function? It is in integers. That's the reason we can say linear function. But how can we prove it?
Well, this is like a slope, right? Because for
no, because look, they are integers. A slope on something like that is usually for real numbers, right? You have some points. That's correct that, for example, if you draw a line, but we want to prove it, okay? We want to prove, for example, it is something, a slope, as the slope you said, for example, ax plus b, something like that. How can we prove this? A rigorous proof.
I don't know about ludicrously, but
You should, as a hint, you should use telescoping sum.
okay. Well, I'm kind of confused because if we prove prove that the difference between every because the domain is only integers, so if you prove that the difference between like fn and fn minus one is always constant, is that not enough to say that it's a linear function?
No, it's maybe the subtract mark. You should, because it's not hard to prove. You write it like this,
Oh yeah.
and you write it like this. So when you can write it in only less than 1 minute and prove, it's better to write. Okay. So consider f of 0 is c. So you can say f of n is mc m times n plus c. Okay.
Yeah.
Or you can say f of x is mx plus c, but with proof for x at least 0, right?
Yeah.
Here when n is negative, positive. If n is negative, then f of n or f of n minus, so for negative, what can we say?
For negative, um, yeah, isn't not, it's the same, right?
No,
You can still say fn.
it's not. It's same, but the calculation is different. Because you should
Oh,
add 1 to reach 0, okay? n plus
okay,
2
so
minus f of n plus 1 is, you add until reach f of 1 minus f of 0, right?
so you get
Let me check it again. Here, n
f
plus
of n
2.
plus 1 minus f of 0.
So it would be cancelled like this, right? Okay, so f of n plus 1 plus f of 1. F of 1 is what here? Because for positive we proved it is m plus c. Is equal to m times n plus 1. M here will cancel each other out, so f of n plus 1 for negative numbers. It was better to write n here, okay? You can prove it like this for n plus 1, but because it's, you can say also like this, mn minus t. So f of n, you should decrease n by 1. So it is mn, what's the problem here? For negative numbers, let's do something. Let's say f of n minus f of n minus. Oh, sorry. Here, f of n will be left, not n plus 1, right? Okay, so f of n would be what? Would be mn minus c. But here, why it is mn minus c? Oh, I understand. Here again, we have another. So it is negative f of n plus f of 1, right? It's m times n plus 1. M and m will cancel each other out. So negative f of n is mn plus c minus c. So f of n is negative mn plus c. Why? For negative, it would be this. I want just again. So when you add, do you agree? Last one, if I write, last one is f of 1 minus f of minus 2 is m. Then you say f of 0 minus f of negative 1 is m, right? This part now is, for negative is a bit confusing. Understood now?
Yeah.
So it would be f of minus f of n plus f of 0, which is c, is m times what? M times n, right? Is it correct? 1 to n. Negative 1 to n. N is negative, okay? So from negative 1 to n, it's negative n number of them, right? So f of n then is mn plus c. It's exactly that. Understood or want me to explain?
Understood.
Okay, so here also for negative numbers, f of x for x negative. So for all x that are integers, f of x is mx plus c. C is f of 0, and m is f of 2 minus f of 0 over 2, right? Then what? So if you don't prove this part and say only linear, probably they subtract, for example, it's IMO problem out of 10, 1 or 2 marks, okay? Okay, now then we should do what? Let me paste the main equation.
Now we should figure out what the linear equation is. I'm just trying to figure out what the equation is now. Okay, so m equals 2 is one solution.
M equals to 1 solution. So let's check. F of 2a is what?
F of 2a is 2am plus c.
F of 2f of b is what?
2mb plus 2c.
What about right hand side? F of a plus b is what?
M squared a plus b.
No,
plus
first
c
m a plus b plus c.
Okay.
Then m squared a plus b plus mc plus c, right? Agreed?
Okay. Yeah.
So then we can cancel c from both sides, right?
Yeah.
So 2am plus 2mb plus 2c is equal to m squared a plus b plus mc. Then we can do what?
I can factor, I can turn it into 2m times a plus b.
Yes, but we can factor what?
Well, I'm trying to factor the a plus b.
Let me tell you something. When you reach something like this, and it is correct for all a and b in integers, okay?
Yeah.
Consider them as two polynomial. I think I told you this idea before. That if here. I told you if two polynomials are equal for more than maximum of degree, then related corresponding coefficients are equal, right?
Yeah.
But here it was only for one variable, right? But here we have two variables, a and b, right? So try to use something like that and consider corresponding coefficients and then find m and c. Okay? Because it is correct for infinitely many a and b, it is correct. Right?
Okay.
So try.
So what do I do? I don't really.
Okay, so let me tell you. Suppose, for example, a is 1, okay? Then 2m plus 2mb plus 2c is equal to m squared b plus 1 plus mc, right? Do you agree it is a polynomial in terms of b, m, and c are constant, right?
Yeah.
So corresponding coefficients should be equal, right? Because it is correct for these two are equal for infinitely many b. The degree of polynomial here is 1, here is 1. If they are equal for more than two values, for more than one values, then corresponding coefficients are equal. Agreed? Or one?
Okay, is it a polynomial on b?
It is a polynomial in terms of b because only b can change. All other terms are constant.
Okay.
It is a polynomial in terms of b with degree 1. It is a polynomial in terms of b in terms of 1. Okay?
Okay.
So, we
You
know
get
P of B is equal to Q of B. The degree of P of B is what degree of P?
It's first degree.
Because the degree is 1.
Yeah.
We proved here if two polynomials are equal for more than the maximum of degree, then corresponding coefficients are equal. Here, maximum degree is 1. If they are equal for more than one value, then corresponding coefficients are equal. We know they are equal for infinitely many b's, right? So corresponding coefficients are equal. Agreed?
Yeah.
So corresponding coefficient. Let's consider coefficient of b first. It is what on left hand side?
2m.
What about right hand side?
M squared.
What about constant term?
2m plus 2c.
On right hand side?
M squared plus 10c.
So from here, what can we conclude?
M equals 0 or 2.
So if m is 0, then we can say what for next
C
one?
is 0. C is 0.
C is 0, so f of x is 0 always, right?
Yeah.
For this one, if m is 2, then what can we say?
You can't say anything about C.
4 plus 2c is 4 plus 2c, always correct, right?
Yeah.
So f of x is 2x plus c, right?
Yeah.
Now, again, when you reach this, look, at the end you should check and reach something that you should reject or check it and say it's correct. So let's check first answer. F of x is 0. So does it work?
Yeah.
0 plus 0 is 0. It's okay, so it is our first answer. Next one. F of x is 2x plus c. So this one is what? Can you tell me left hand side?
That's wait. 2 of a, so 2 times, so 4a plus c.
Yes, plus
2 times 2b plus c.
exactly is equal to
2a plus f of 2a plus 2b plus c
is equal to
4a plus 4b plus 3c.
4a plus 4b plus 2c plus c, right?
Yeah.
Then what can we say? 4a.
So
If we
just say
simplify here, 4a we want to prove are they equal? 4a plus 4b plus 3c. They are equal, right?
Yeah.
C can be any number. C is an integer, right?
Yeah.
It was f of 0. Okay, so we proved also this, right?
Yeah.
Okay, so as you saw, we solved all these problems with the idea. We have also harder problems, but only till this part is enough to consider fixed points and something like that. But you can solve 90% of the problems in IMO, USAMO, JMO, BMO with these ideas, okay? And let me tell you also something